Hello, we are taking notes on distance formula today. This is 1.3 distance formula. And be sure that you write today's date. So the distance formula is used to find the distance between two endpoints. We could also think of the distance between two endpoints as a length of a segment. So, to find the distance between 2 points, or length of a segment, use the distance formula. Now I am going to use two different colors here, so I recommend you grab that. And I'm going to start by writing out the distance formula. So D equals the square root of, and then inside my square root, I'm going to have x2 minus, I don't like that color, let me change that. x2 minus x1, so I'm subtracting my x's, squared, plus, and in a different color I will put y2 minus y1. Now recall from midpoint we already have used x1, x2, y2, and y1, and that comes from 2 points that we have. So we have a point x1, y1, and then we have a second point, which is x2, y2. So these are our 2 endpoints. That is a 2 there. So what do we have when we take x2 minus x1? This is going to be our horizontal distance. Remember, we have used this set of our delta symbol and x to represent horizontal distance. All right, and when we are subtracting y2 minus y1, this is finding our vertical distance or change in y. Now, y is the vertical numerical part of my point, which is why this is vertical distance. Okay, so we have our distance formula. Now let's get into using it. And I am going to use a grid for this example because I'm going to draw a graph. So if you have time to stop and prepare yourself, or possibly get a piece of grid paper. All right, let's do example 1. We are going to find the distance between 2 points, and those 2 points will be 1, 2, and 4, 6. All right, so I'm going to get into drawing my graph. This is going to help me understand how the distance formula works. So draw yourself an x and y axis and plot each point. So at 1, 2, that will be right here. That's my first point. and 4, 6 is here. That is my second point. And I have this segment here that I want to know the length of, or find the distance between. So first I want to relate this to how we have been looking at midpoint and counting that horizontal distance and vertical distance between our points. This helped us find the midpoint, and it's also going to help us find the distance. So the distance between, the horizontal distance between these 2 points is 3, and the vertical distance between these 2 points is 4. So I'm going to remember that as I work through the distance formula. Now, with the distance formula, I would first want to label my points as I did for midpoint. So this is my first and second x, and then here I have my first and second y. So to recall the formula, I'm going to take x2 minus x1 squared plus y2 minus y1 squared. All right, I want to take my numbers from my points and replace or substitute into my formula. So first I should be taking my x2 and x1. So 4 minus 1. I am going to close my parentheses and write my squared exponent of 2. And then I have 6 minus 2 for my y2 minus y1. And that is also going to be squared. So in the distance formula, we have subtraction within the parentheses and then addition to connect. All right, I want to work this out solving the parentheses first. So 4 minus 1 is 3. So I'm going to have 3 squared plus 6 minus 2, which is 4. And so what you should notice at this point is I ended up with 3, which was my horizontal distance, and 4, which is my vertical distance. And that's connecting back to actually how it looks on the graph. So if I wanted to skip a couple steps, I could start my problem from this point here because I can count what I would get when I subtract my x's, and I could count what I would get when I subtract my y's. All right, to continue solving the equation or simplifying, I want to square 3. So 3 squared is 9. 4 squared is 16. I will add those together to get the square root of 25. And I know that that is going to simplify to a whole number integer. And the answer is 5. Now I want to make note here that 25 is a perfect square. When my answer ends up being an integer whole number, the number that came before was a perfect square. All right, and we're going to go through one more example in this lesson. For our second example, we again are going to find the distance or length. So this time I will say find the length of the segment with endpoints -1, 1, and -6, -1. All right, so again, I do want to graph this to reference how it looks and help us understand the problem. So we are doing things two ways. We are doing things on a coordinate plane and algebraically with our formula. So first, to graph the 2 points, 1, -1 is here, and -6, -1 is here. So I have this segment that I would like to know the length of. Again, first I'm going to check out my horizontal and vertical distance. And I see that I have a vertical distance of 2 and a horizontal distance of 5. So I should see those numbers come up as I'm using the distance formula. Again, I'm taking x2 minus x1 squared plus y2 minus y1 squared. All right, time to label my points. These is my x1 and x2, and my y1, y2 into the formula. So x2 is -6 minus x1 is -1. So I'm actually going to make sure I write two negatives, so minus a negative. I do have a double negative there. Then I need to add that to y2, which is -1, minus y1, which is 1. And that quantity will be squared. Okay, so now to solve in my parentheses. So what am I doing in this step? I am solving in the parentheses. -6 minus -1, I need to think of this as addition. So it's no longer a -1 when it is a double negative. So -6 plus 1 is going to come out to -5. I'm going to end up squaring that quantity, which is very important. And -1 minus 1 is -2. Squared. Now, always in the distance formula, if I solve my parentheses and I get a negative here, after this step, I will no longer have negatives. What is the step? It is to square the quantities. Okay, so I'm doing that, raising that exponent of 2. After I do -5 times -5, I will have a positive 25. A negative times a negative is positive. -2 times -2 will give me a positive 4. So at this step here, no negatives. Only positive at this point after I square the quantities. Then finally, I'm going to add those numbers together and I get square root of 29. Now notice this number here is not a perfect square. So I'm not going to get a nice integer answer. I'm going to have to stick that into my calculator and find out the decimal for square root of 29. Now, you may be able to estimate and know that the perfect square that is very close to square root of 29 was used in our last example. That was 25. So I would expect my number to have a 5.75 some decimal point. Now in my calculator, I'm going to put square root of 29, and I see I was right. It is 5.385. I'm going to take that back to my notes. 5.385. Now I do want to talk about rounding here. So if I am rounding to the tenths, that is going to be my first decimal place. So it goes tenths, hundredths, thousandths. And after my first decimal place, I want to look at the following number. So the following number is 8, and if that number happens to be 5 or more, which 8 is, it is going to tell me to round my tenths digit up. So I would round this answer to 5.4. And that is my final answer for the distance between these 2 points. That concludes our lesson. Thank you for watching.